Welcome back, my DIY nomads. Just a quick little side note. Yes, I know this is a re-upload. The reason being for the re-upload is that in the video I discussed voltage sensing relays as a way to charge off of your van starter battery or from the alternator. Voltage sensing relays work fine with any van that doesn't have a smart alternator, but a lot of vans these days are getting them. So the way you charge, if you have one of these smart alternators, is to use a DC to DC charger. And because obviously I want to try and push as much good knowledge as possible through this channel, I'm going to be taking down the previous video, re-uploading it with this information. I'll also do a little tweak later down in the video. It just makes it easier for everyone and no one's going to have any nasty surprises in the future. One thing I'd like to say before we get into this video is that if you are unsure about electronics, even if you are sure about electronics, I would definitely consult a qualified electrician. All the information in this video is coming from me. I'm not a qualified electrician, so obviously I would take this with a pinch of salt, and I would advise that you get advice from a qualified electrician. Anyway, let's get into the video. Welcome back, my DIY nomads. We are back again for another episode. In today's episode I wanted to revisit 12 volt electrics. It's been one of my most, if not the most popular video that I've done a couple times now on the channel, and I want to revisit it. Let's look behind me here at this I'm going to take you through the most basic 12 volt system and explain a few things along the way. So yeah, let's look at what we've got lined up here. Right below me here is an 85 amp hour battery. It's actually there's quite a lot of detail about batteries. I'm not going to be able to cover it at all in this video, but this is rated at 80 amp hours for a 20-hour discharge, or an 85 amp hours at 100-hour discharge. That is a whole nother video to talk about. You can find plenty of those online as well, but for ease of use we're going to say this is an 80 amp hour battery. This is lead acid. And what we have is we've got the positive off of that battery going to a shut-off switch here that you can shut off in the case of an emergency or anything really, just to isolate the battery completely from the system. Off of this comes the positive to the 12 volt distribution board. You can have plenty of things coming out of this isolator switch, but for this very simple system we've got this 12 volt distribution board. So this one has 12 ports, so you can attach 12 different electronics to this and fuse them all separately. The reason I like these is because they do just take a lot of work and messiness out of a system, simplify it and keep everything in one place so that if a fuse does go you can find them all in one location. So we've got the positive going to this board. This one actually has two separate ports here. This one side here is powered separately to this side here. If you want to join these together, you could join these two terminals up, and then the one battery source that you have, the one power source you have, could power all 12. At the top here we've got two fuses. They are of different amp ratings. The top one is 3, the bottom one is 25, and I'll explain that in a second. At the very top is the negative terminal to the battery. This literally just links back to the negative terminal on the battery. We've got the negative attached to the top. That means that on this 12 volt distribution board, all of these screw terminals at the top here, these are all the negative terminals. So this is where all your negative ports will come back to. The nice thing about this distribution board or something like this is it comes with this plastic cover there so that nothing can touch it and short anything out, but it also keeps everything housed in and avoids it from getting bashed or maybe even a splash of water or dust. Now off of this I have got two cables that seem an odd colour to go for in a 12 volt system. They're white and brown. I wanted to show this because sometimes you will get a kit and the colours of the cable can be different from your usual red and black. It's nothing really to worry about at all, but I do know this can get a bit confusing when you go to shore power, like 240 volt, like plug into the wall, because brown in shore power world is live. You've got the brown is your live, the blue is your neutral, and the green yellow is your ground or your earth. Anyway, back to 12 volts. So we've got the white here is the positive, and the brown is the negative, going up to a switch here. I kept it all on show to hopefully try and simplify this, but literally that switch just allows me to switch the LED strip on and off. This really is pretty much as simple as it comes. I'll show you one of these switches up close. With these rocker switches, the top gold terminal, that is the negative of the earth. The middle is the load, or the appliance that you're powering, and the bottom one is the supply. So if we look at this switch here, what you want to do is actually have all of these sheathed or have a heat shrink around the metals of the terminal, so there's no chance of them arcing across, but I've left these out and exposed to basically make this easier to see. We have, from the positive of the battery going through the distribution board, which goes through a fuse and up this white cable, that's going to the supply terminal on the switch, the bottom silver one. Then in the middle, the red connector here, that is going to the positive of our appliance. In this case, it's an LED strip. And then on the top there, with the gold one, we actually have the negative of the LED strip and a negative cable in the same connector going to the top gold connector. And then that comes down and goes into the negative point on the distribution board and then back to the battery, completing the circuit. Another thing you can do is make something like a control panel, like this very basic control panel here. This literally just has a switch that turns on a cigarette lighter port and a voltmeter that shows me the percentage of the battery and the voltage in the battery. So if I switch that on, light comes on, this comes on, and now I can get power to my cigarette or 12 volt port. This has a little button that allows me to switch between off the battery percentage and the battery voltage. You might have noticed this little bus bar up here. These are called bus bars. They're very useful to have like near the back of a control panel because you can connect one of the terminals to the negative that goes back to the negative on your distribution board or the negative on your battery, and then instead of running loads and loads and loads of cables, negative cables all the way back to your battery or your distribution board, you can just run them all to this point, and then they will eventually get back to the battery, and that saves you having to use loads and loads more cable. So here we've seen how you can have an independent switch powering something in a completely different area to where your control panel is, and from your control panel it also shows you how to power multiple objects. You can also, off the back of that switch, like the LED strip, you could have a couple more switches in the control panel, and you could power anything like a fridge or the electric clicker for a propane hob or anything like that. You just have to follow a similar wiring setup as the LED strip up here, but you just obviously have the switch on your control panel. From there you can also run the negative of your fridge or whatever it is either back to your bus bar, the negative port on the distribution board, or even just straight back to the battery if it's actually closer. To show you how this is wired up, obviously the power coming through the distribution board through a 25 amp fuse along this cable, which then goes into the supply port of the switch. So this is the supply port from the power. Then I have the positive from both the cigarette port and the voltmeter connected into one connector that goes onto the center of that switch. I then have the negative of the voltmeter and the cigarette port going to this terminal, which actually has three cables in, because we've got the negative from the cigarette port, negative from the voltmeter, that goes up to the bus bar, which then ends up going to the negative on the distribution board and then down to the battery. So let's say I wanted to add this switch to the control panel that turned on a fridge. I take the switch and I would mount it somewhere on the control panel. I would then have it mounted with the terminal stuck at the back. I would run a positive cable off of a separate fuse port on here and fuse it to the correct amperage of the fridge. That would run all the way along, and I would attach it to the supply terminal on the switch. Then the positive in the center would go straight to the positive on the fridge, and then the negative terminal will connect to the negative of the fridge and then off to the bus bar or the negative terminals on the distribution board that will then go back to the battery. That still might not be very clear to everyone, so if you are still confused, please ask a question in the comments below. There is one major problem with this system as is right now, and that's nowhere to charge it. So we can go about multiple ways to charge a leisure battery in a camper van.
Ice cream, ice cream, ice cream!
So as I was saying, there's no way to charge the battery, so let's add a system. There are multiple ways to do that. Two of the best are obviously solar and using a voltage sensing relay. Some things I'm going to come back to on this video are wire gauge and a few other details about different appliances. So make sure you watch to the end to see some very important details. Let's start with voltage sensing relays. This is a voltage sensing relay here. Basically what it does is, in the simplest way possible, once you start driving, this detects the alternator kick in as the voltage spikes to charge the starter battery, and then this allows that power to also be siphoned off and charge your leisure battery. In the kit, you can get loads of kits. This kit costs about £70 to £80 and it came with absolutely everything, except for obviously tools to sort of do stuff like terminal crimping. I have these meaty boys to do that. You can get away with like sort of your basic crimpers in like terminal tools as well. These are actually wire strippers that come with them as well, but there's quite a few ways to do it. Obviously the more specialized tools is going to give you a better result. The way this works is the power comes in through this is actually a 60 amp fuse into the VSR here, and then comes back out from the other terminal through another 60 amp fuse and off to the, we've got it put into our cutoff switch here. So you've got two terminals at the back of the cutoff switch, one terminal that goes to the battery and the other terminal that connects to everything else, like the distribution board, the solar that I'll show you in a second, and obviously the voltage sensing relay. On the back of this voltage sensing relay there are two terminals, one that is for the starter battery and one that goes off to the leisure battery, as I just mentioned. But then there's also this black cable. Now this black cable just needs to be earthed, so you can attach it to somewhere in the van chassis. You can also attach it to the earth. If you put this near your starter battery, you can put this onto the earthing point on the starter battery. But you can also attach this to the negative on the leisure battery, which needs to be earthed as well, which I'll show you in a second. So you've got the positive from your starter battery through a fuse into the voltage sensing relay, then back out through another fuse to what is technically your leisure battery positive. You do also need to have a cable coming off the negative port on your leisure battery and attaching to the van chassis in some way, like basically the bare metal of the van, to earth this battery. Smart alternators. A lot more vans these days are getting smart alternators, and if you have one, then a voltage sensing relay won't be able to work with it, so you're going to have to get yourself a DC to DC charger. But how do you even know if you have one? Well, usually you can search it online in forums because people have already asked this question, or if you have a multimeter, you can turn the van engine on, make sure that all of the radios off, the lights are off, all that sort of stuff, take a reading across the battery, wait 5 or 10 minutes, and then take another reading. If the voltage is coming out at around 14.4 volts, then you probably don't have a smart alternator. If the reading's coming out about 12.5 to 13.5, then you probably do have a smart alternator, and you'll probably have to go for, you will have to go for a DC to DC charger. Now there's a few options on the market. On screen right now is a very nice Victron Orion. Looks and works in a very similar way to a solar MPPT charger, where you have your positive and negative wires coming in and then the positive and negative wires going out. Here's a wiring diagram from Victron themselves. You will also have to fuse those positives in and positive outs so that you protect your system. Another good alternative is the C-Tech D250 range. I can personally rate these really well. I had the first one, the D250, then I had the D250 the D250S, and then I had the D250 SA, and I think we're now on to the D250 SE. They're great. They are your solar charger and your alternator charger all in one box. It has 4 larger terminals on the top, and then a small dual cable, like positive and negative cable, that come out and that connect up to a fuse point on your van. And these will handle both vans with and without smart alternators. A very good, easy, all-in-one system. Now on the other side, you can also charge your leisure battery using solar, and the electronics part of this is actually really simple. What I did was I had a few parts from a kit lying over. This is actually a PWM controller, but I would say you're going to do much better if you use an MPPT charger. The MPPT chargers just seem to charge at a higher efficiency. It's down to the way they work. If you want to learn more about that, check it out online. But yeah, basically MPPT is probably going to do you a lot better. On all these solar charge controllers, you're going to have basically these 6 ports on the bottom usually. There's a positive and a negative from the solar panel. There's a positive and negative that go to your leisure battery, and then there's a positive and negative that's called it's like a load. So basically it has like this little light bulb, and that can provide power straight out of the charge controller. You don't really need to worry about those two, so really we're going to focus on these 4. We've got the positive from the solar panel that goes through one of the fuses out into the positive terminal on the charge controller, and then the negative from the solar panel that goes to the negative terminal on the charge controller, and then out of that you have the battery. So we've got the positive that goes yet again through another fuse and then off to the leisure battery, and then we have the negative that comes out and also goes off to the battery. One other thing you can also add between the VSR and the isolator switch, and also the solar charge controller and the isolator switch, is a further isolator switch, so that you can individually shut down each system. It's less of a worry on the voltage sensing relay, but because while you have sunlight you will be passing current into the leisure battery unless you trip one of these trip switches, you might actually have a pretty good reason for wanting to isolate off the solar. So I would advise you actually whack an isolator switch on the positive from the fuse to the leisure battery. If you can't afford that, then you can literally just trip the fuse, and then no power will be able to get to the leisure battery from your solar. So I've connected the solar panel, and if I flick this switch on, it will allow power from the solar panel to get to the solar charge controller, and as you can see all the lights have come on, and that is actually happening right now. And then if I switch this other one, that now allows power to go from the solar panel all the way to the leisure battery, so we're now charging the leisure battery using solar. They usually have a series of lights to show you what's happening, and usually they come with a handy guide to tell you what each like flashing light or solid light means. But really, other than actually fitting solar can be quite tricky, like depending on where you have to feed the cables through and stuff like that, but really the actual electronics of solar stuff is very basic, along with the voltage sensing relay. Another way I forgot to mention that you can charge up your leisure battery and also get 240 volt into your van is to use a 240 volt hookup kit. These kits, I've mounted one on the wall behind me, so I'll show you how that works, but these kits usually just come and they supply you with 240 volts from shore power to your van. If you want to charge your leisure battery, you will also have to add an AC to DC charger, one that works for your plug in your region, in your country. But I'll show you how this little kit fits up. The one really annoyingly stupid thing about this kit is I don't know if they've got this wrong, but actually they supplied me with the female one, and usually you'd want the male connector. So I'm just going to have to wire this up to a standard UK plug and plug it into an extension cable so I can show you guys. Yeah, I don't know why they've given me that connector, but I thought I'd just show you visually as an example. Other than your shore power plug, most likely you'll have 2 plugs that come in here. I haven't wired this up yet because I want to show you it getting wired up, and then you'll get like this little mini consumer box and all of the cables and everything you need usually in the kit. One thing I want to say at this point is, yet again, I'm not a qualified electrician, so I would advise you get an electrician to fit all this. Take everything I say with a pinch of salt. I'm literally just showing you this kit. I've installed this as the fitting instructions say. Right, so some of these are actually, these little consumer units are structured differently in some, like between different companies, but what you'll usually get is a neutral bar, an earthing bar, space, like a DIN rail, like a little rail behind here that you can attach all of your fuses, etc., to your circuit breakers and everything to, and yeah, that's really it. with these little tiny consumer units, they are great because they are very compact and a neat little system. Basically you have your RCD here and two little circuit breakers. You'll see on here it's rated like B6, B10, that's 6 amps and 10 amps. The letters also correspond to different sort of types of circuit breakers that perform in different ways, but we don't need to get into that. You'll basically get everything you need in the kit. So yeah, we have at the bottom of this box right here, we have 3 cables going out. Obviously the cable to this plug, which I'll explain in a little bit, the shore power and the earthing cable. This earthing cable goes to the earthing point, like your leisure battery, to the earthing point on your van, and then you have your power in. I'm going to say it right now, nothing is plugged in, there is no power going to this unit at all. So yeah, remember that whenever you work on electronics, make sure everything's turned off so there's no chance you can get a shock. This little Arctic blue cable that comes in, this is our power in, so that is supplying the whole of this 240 volt kit. So that comes in, and it is a 3-core cable. So on the inside it will have the same as the white cable here, it will have a blue or neutral cable, a brown, which is called a live cable, and a green and yellow, which is an earth cable. That is literally coming in, and the earth cable is going to the earth bar, and then the other 2 cables are feeding up the back behind this little DIN rail, up the top. So we've got the live from the shore power going into the live point on the RCD, and then the neutral going into the neutral point. And then out the bottom we have this very chunky neutral cable that goes up the back again and into your neutral bar. On the actual supply side though, so we've got the live coming in and then coming out, that you usually get them in the kit. It's a copper bar that has a bunch of teeth on it, and that allows you to connect from the supply out and then supply all of your fuses, because these bars do get quite long. You can apply all your fuses off of this one little connector, and now these fuses, when the power comes in, these fuses now have power to supply out the top. If you wanted to add a plug, which come in the kit, you would then take your 3-core cable, which is in there and wide to the back of that plug. It also comes out the other side, comes up through, and the earth goes to the earthing point. The live and the neutral feed up the back here, and the neutral now goes to this neutral bar at the top, and then the live just goes into the live feed of the top of the circuit breaker. I'm using the 6 amp fuse in this kit. They usually come with a 10 and a 6. The 6 amp is going to go to this plug, and this is the plug that I would plug in my AC to DC charger, because I don't need more than 6 amps. And then the 10 amp will go to this plug, which I would use, for instance, for something in the van like a microwave or a kettle, something that uses a lot of watts to power. Now, if you wanted to add another plug to your system and you have a free circuit breaker, do that. You can fit your back box of your plug or wherever it needs to be, and then you take the front point, and in the back here you'll see that of the back of the plug there's going to be a live, a earth and a neutral point. The live taking the brown cable, the earth taking the green yellow cable, and the neutral taking the blue cable. I've actually got this secondary cable coming out here because I'm going to also earth it to the little earthing point in the back of the box here. So now that, providing you've pre-fed the other cable, you could just basically close that box up, screw the top on, and you've got a wired up plug. The other end of your cable from your plug, you're going to have the same 3 cables. I'm going to feed those up. As I said, the live and the neutral are going to feed up the back here and come out the top. The earth is going to go into the earthing bar just at the bottom here. The neutral is going to go into the neutral bar at the top here, and then the live is going to go into the top of my other circuit breaker, the 10 amp one. Right, so if you follow the kit and it's all gone well, or an electrician is fitted for you, you should have your power supply. You should have your power supply in, your earthing cable mounted, and your 2 plugs wired up, ready to rock and roll. To show you that this is all working and that I'm not just taking you for a ride, we've got everything closed up. So before you turn anything electronic back on this, make sure that it's all closed up, it's all safe. I'm going to make sure they're all off to start with. Right, so I've just plugged the system into the mains, and I'm just going to switch on the 6 amp plug for now. We don't need to switch on the 10 amp. And I'm going to plug something in to show you it's all working. Actually got a little heat gun here, so it's quite a demanding little device. So there you go. That is a fully working 240 volt hookup kit. But we're not charging our leisure battery, so how do you do that? The easiest way to do that is to just simply get an AC to DC charger, a power charger, the one that will convert your plug at home into the voltage and current needed to charge up your leisure battery. But all that would do is simply plug into your plug here, you'd mount it on the wall, and then you'd take the black and the red, usually the positive and the negative cables, and you would attach them to the negative terminal of your leisure battery, and then the positive will go into the side of your shut-off switch here, so that you can keep everything shut off if you need to. But really it is that basic. So once the 240 volt kit is in, it's really basic to take that and then convert it to charge up your leisure battery. It's just one little unit that does all the work. It's already fused in there as well. So I don't have one here to give you an example, but I've just actually recently used it on another project, so I don't have it here to show you. So now we've basically got a full-fledged system. It charges when the van's driving, it charges from the solar, and you're powering some of your gadgets. A couple of other things that we need to mention though, stuff like wire gauges, cable fixings, fuse sizes, etc. So let's get into that side of things. There's a couple different options you can use for cable fixings. I prefer the sort of like these plastic nylons. You can also get metal versions, basically ones that screw down and hold your cable in place, just because they are way more secure, way more permanent. But sometimes it's not always an option. You can't always screw into something because either the material isn't good to screw into, it's too thin, or you might not have metal tapping screws. You can use adhesive mountings as well. So I have these ones which are like, they're square and they have like a grid system in them, and what you do is you stick those in and you feed a cable tie through the holes there, and you can attach the cable to the top. This up here, that is one of those adhesive ones, and actually they also do come with 2 holes there that you can use to screw down with if you really need to, but you have to use very small screws. I prefer these sort of style, like I showed you before, the nylon style ones. These are much more permanent, much more secure, and just a better option all round. Next, wire gauge, really important thing to talk about. All the wires on this system are of varying thicknesses because they need to handle certain amounts of amperage. At the workshop we have a few different spools of cable here, so this is just a spool of red cable. This cable is rated for 17.5 amps. It doesn't really matter what length that is, within reason. It doesn't really matter what length of cable that is. It's going to handle 17.5 amps, but if it goes really long you might experience a voltage drop. I get all of my cable from Auto Electric Supplies. They aren't sponsoring this video, but that's just where I get this cable from. And yeah, we have loads of different sizes so we can use it for all the different applications that we need to. Now you may be wondering, how do I find out what cable gauge that I need to use for my system? Now there's a couple ways to do that. Usually the best way is to look at the bottom or where the information label of your appliance is, or the thing that you're using, and find out either what amps it draws or what watts it draws. If you know what amps it draws, that's great. You know sort of roughly what cable to, you know what cable to buy, you know what cable to use. So with this 17.5 amp cable, if I had an appliance that drawed 15 amps worth of current, I could get away with this cable quite happily because it's got a little bit of a buffer to it. But if you, for instance, look on the bottom, quite a lot of the time it might say the watts. The easiest thing to do is just go online and use a conversion table. There's plenty of them online, and then you can use those to find out what amperage your device is drawing, and therefore what cable you need to use. So off of the battery to the isolator switch, we have a very thick cable. This cable can handle around 170 amps. That's going to handle way more than what you're ever going to need in this sort of system. Hey everyone, Hugh from the future here. Just a couple of points I want to add in here. When you choose your cable, try and choose a cable, well, preferably copper as well, but choose a cable that has a higher strand or core count. You want it to be as flexible as possible, because in a vehicle you're going to be driving around, there's going to be vibration, there's going to be movement, and anything that has fewer or much less cores is going to could end up being bent so much that it actually ends up fracturing inside the cable, and that's a nightmare. So choose a higher strand count, because then it'll be able to flex much better and last a lot longer in a vehicle environment. The only negative about having more strands is that it carries less amps than a cable of the same size with fewer strands. So if you had, like the 170 amp cable I used in there, it was a 322 strand cable. So it has 322 strands of copper inside that PVC coating. But if I had something that was like 3 core, it would handle a lot more amps, but it would be super rigid, and I wouldn't want to use it in the van because I wouldn't be able to really bend it without very much without it breaking. And then basically the cable off of the isolator switch to the control panel, you really sort of have to think about what's going to go into your van. So if you have a fridge and a fan and all this sort of stuff, everything that's going to come off of there and through this distribution board, you've got to think about all the amps that are going to go through, and this cable has to be able to handle all of those. So you need to choose the right rating. And then same thing for all of your applications. So this cable that comes off to the control panel that powers the cigarette port and the voltmeter, I wanted to provide a thickness of cable that would be able to handle 25 amps, because I've used a 25 amp fuse. So this cable is rated for 27.5 amps, because you always want to give it a little bit of a buffer. There isn't many reasonable things that you would use through this cigarette port here that would end up over using this cable, and if it did, that's what the fuse is there for. It'll blow the fuse, and you know you've tried something too power hungry for that port. With the control panel here, just something I quickly wanted to mention. I chose the sort of like more traditional cigarette port style connector because I think they're just more functionality to them. You can get the ones that they use the same connectors on the back, they're basically the same shape, but they're already made into USB ports, and that's fine. You know, you've always got USB ports in there, but it's very limiting. There's 2 ports on here, one's 1 amp, one's 2.1 amp, but as technology gets better and better, you actually notice that this gets completely outdated. The advantage of having just the normal port like this is that you can keep changing up your application that goes in there, but also you can change up your USB ports as well to keep up with the technology that's going out there. With LED strip though, you can go to very small fuse sizes. This is only 3 amp. Obviously the longer length of LED you use, the higher the wattage, the more amps it's going to draw in the end. But you can also get different types of LED. Next thing I just want to quickly cover is LED strip. A lot of us use it in our camper vans, a lot of us use it in many situations, and you can get quite a few different types. You might have heard numbers like 3528 or 5050, 5050. You can also get LED tape that looks like this. It's just sort of like bare, or you can even get it with like what looks like a sort of silicone coating over the top. This sort of stuff is like waterproofed, and this stuff isn't. So I usually still go for waterproof stuff in a van just for, you know, so I don't have to really worry at all. But really, you can definitely get away with having the unwaterproof stuff because it's cheaper and it's less likely to overheat as well. But yeah, let's talk about the numbers. So you can get stuff like 3528 or 5050. There's a few different numbers. They basically correspond to the size of the LED and how powerful they are. You can also get sort of like within that category, you can also get how many are in per meter. So you might end up with 30 per meter or 60 per meter. So there's like loads of different ways to go down the LED strip route. You can choose what, yeah, as I said, you can choose what waterproofing level, how bright and powerful they are, how dense they are. You can also choose colors. So for instance, this stuff here that I bought, this is actually it's a warm color. You might see it called like K rating. So like 2800 would be quite warm, whereas you go up to like 8K or 4K, that's like more of a bluey white color. You can also get RGB and even RGBW or RGBWW. So RGB is your, like, I guess your classic LED strip, the one that has multiple colors, the ones that change color and can do loads of different, like, sort of different effects. They've also brought out now sort of the more newer style of things is RGBW or RGBWW, and that literally stands for RGB LEDs in, and also white LEDs in there. So you can get the full spectrum in one strip, which is pretty cool. The one that's RGBW just means red, green, blue, white, and then the RGBWW is red, green, blue, warm white. So you get like a warmer white, which is the one I'm actually going to look at putting into the Peugeot Boxer. The only thing I would say against RGB and like all those ones that are multiple colors is you do have to use a driver with them. The driver allows it to sort of something like a controller to control the different colors and brightnesses. So they're a bit more complex, whereas if you just go for a solid color, like white, should we say, like one color like red, you just need to connect them up to the positive and negative. The RGB stuff usually has 4 cables, and that allows it to control all the different colors in the strip. Now, to any eagle-eyed viewer, you may have noticed that some of these connections, I haven't actually put connectors on the end of the wire. I've just put the actual frayed edges into the sort of ports and screwed them down. That's not advisable. I wouldn't recommend you do that. I did this because I'm trying to save. I don't have like loads and loads of connectors just lying around that I can waste on this video. But you can get yourself like connector boxes, and they can come with like loads and loads of different shapes, sizes and types of connector heads. You basically need to grab one of those and a crimping tool that's specified towards these sort of types of connectors. You can then take your cable. I'm using this wire stripping tool, but you can just use normal pliers. This just makes it way quicker and easier. Strip the end, twist it, and I'm just going to use a standard sort of blade connector here, just because I have a lot of them and I don't need to worry about wasting too many of these. And you just sort of slot it in, and on this crimping tool I have the yellow, blue and red that correspond to the different colours. This one's a yellow, and then that is that connector all done, ready to rock and roll, and you can use it for whatever you need to use it. One thing to also consider is, in most scenarios these connectors will be fine in sort of a 12 volt system, but if you are drawing a lot of amps, you might need to check what the actual max amp rating of these connectors are, because if you go too high, they might be too thin, you might actually end up melting the connector heads before you melt the wire, or blow a fuse. Hopefully though that won't happen. Another little thing to think about is like terminal connectors. Sometimes you might need to join two ends of a cable together, and I quite like to use this stuff. It's quite standardized in the electrical world. I can't remember the name of it off the top of my head. I'll put it on the screen right now. That's sort of like quite a good strong fix. You basically, there's screws in there and you can screw the cable in from the top and the bottom, and then so you'd have like, for instance, the positive coming in and the positive going out, and then negative going out. Less permanent options, you could choose stuff like these connectors as male and female. on the bottom there it has the positive and negatives that you put into, and this gives you a chance to connect and disconnect in your own leisure. And probably another semi-permanent connection is stuff like these Wago connectors, which are pretty cool. You would connect two of the same colour, so positive and positive. If you need to connect to two positive ends, you'd put them in there. You would sort of lift up these two tabs, you'd put the two positives in the holes there, and then you'd close it down, and that would connect those two bits of cable. Right, so we've covered a basic 12 volt system, quite a few different bits of information, so sorry if this video is a bit overwhelming. The last thing I really want to do in this video is to, from this system right here, just add in an appliance to show you the whole process, wiring it in, so that you can find it a bit easier to add your own applications down the road. Now with the control panels, you can definitely go ahead and build one yourself like I've done here. But you can also find and buy ones like I've got pictured on screen right now. These are also pretty good. They're pretty affordable. They look alright, depending on what your taste is. And all the fuses are actually in the back, so all you need to do is run one semi-hefty positive cable to the back, and then connect it up, and that'll power all of them off that one cable. And then you just run the negative back to the battery. That's pretty cool because it means that you just need to run sort of two cables to wherever that control panel is, and then you can power loads of stuff off the back of that. Yet again, I'd advise you use a bus bar, because then you can connect all the negatives in one area and then just take one cable back to the battery. But if you're going down this route, you might want a little bit more than just one cigarette port, so I'll show you how to wire in an extra button that powers something else. One thing I should also add is that these little rock switches, they are rated for 25 amps at 12 volts. Actually, these are actually a little bit higher than usual. It's usually 20 amps at 12 volts, but I managed to find these ones, and the more amps you can get out of it, the better really. So make sure you don't overdo the amps for the switch as well. Right, so let's add, I'm just going to add some more LED strip, but this could really be anything. If this could be the positive and negative for a fridge, or the positive and negative for a fan. You just need to make sure that you're not going to overdo it on the amps for the cabling, the switching, or the fusing. We're just going to actually light up this whole reel of LED. So I'd say we're just going to try and put in probably about a 5 amp fuse for this. Because of that, I've got this 2-core positive and negative wire, and that could easily handle this amperage. So I'm going to use this to wire it all up. So I've now stripped all the ends, and I'm just going to twist them so they go from being frayed like the positive is to twisted like the negative is. So for this bit of cable, I've got the positive and the negative that are going to be attached to the distribution board. With my connectors, because of the size, the gauge of the cable, I can use these smaller red connectors. Right, so I've left the negative bare with the negative which is going to connect to the switch end. I've left that bare for the moment because I also want to connect it with the negative of the appliance, or the LED strip in this case. And so I've had to go for a connector that has a larger sort of cable gauge requirement, and crimped it down. So we've got this setup now, and all I need to do is add one final connector for the positive on the LED strip or the appliance. Now, as I mentioned before, you don't really want to have bare terminals for the switches, because they could bend, touch and short out. So you can either wrap them in electrical tape, or the best option is heat shrink tubing. As I don't really want to waste all my heat shrink tubing, just for this example, I'm going to use just some electrical tape, and I like to have red and black so that I can sort of color code it. Not the neatest job, but it just means that the metal is covered up so it's not going to short out. So we've now got this situation where we have the positive and negative coming off the LED strip and going to this terminal, which is the positive from the LED strip of the appliance, and then the negative going into this terminal with the negative from the cable, and then the positive of the end of that cable with a terminal on, and then at the very other end, the two ends that go into the distribution board, we've got those connectors there. So let's attach it to our system. The most important thing to remember is if you're working on your electric system, turn the power off so there's no more power going to the system. But as I mentioned before, there isn't an isolator switch on this cable, which I would advise for the solar. So currently there is still power going to the system. So make sure you trip that switch, and now there's no power in the system, so you're not going to get a shock. So now we have the negative of the cable going to the negative port on the distribution board, the positive going to the positive. There isn't any fuse in there just yet, but I'm going to connect up this to the switch. So I've got the switch here, as I said before. We've got the golden terminal, which is going to be our earth or our negative, the middle, which is going to be our load, and then the bottom one, which is going to be our supply. So the supply is the positive of the battery, the negative is the negative of the battery, and the load is the LED strip or the appliance. So now I'm just going to choose a 5 amp fuse, turn the system back on. Right guys, moment of truth. Hey, never doubted myself for a second. Jesus, actually they're really bright. One thing to also add about adding this other appliance is that, as I mentioned before, this negative can either come to the negative of the distribution board or the negative of the battery, or even onto this bus bar that's near the control panel to save lots of wires going back and forth. Well, I hope that's pretty much covered most things 12 volt electrics wise. I would like to do some more follow-up stuff on this, so if there is stuff that I've missed, let me know in the comments below, and I'll try and do like a second video to follow up with this. A few cheeky honourable mentions. This stuff here that holds the LED strip, it basically makes it look nice, but also sort of diffuses the glow. Basically comes in two parts. It's sort of like a plasticky lens and then the aluminium extrusion backing, and you can either double-side sticky tape it to a surface or screw it down. For the purposes of this demonstration, I just double-side sticky taped it. You can find that stuff for a pretty good price on, I think it was Amazon. So giving Jeff Bezos even more money there. Also some tools I think you really should have. 100% I definitely recommend getting like a cheap easy multimeter like this. Makes the world of difference. You can use it to find faults and where that fault's happened, so really valuable bit of kit. Other things that you don't necessarily need but make your life a lot easier: wire strippers. These things are great. I can't live without these now. It has a little cutter in there and some crimping tools. I don't really use the crimping tools, but cut the wire and then ready to rock and roll. Great little tool. As I showed you before, the little terminal crimper for those sort of smaller ones. This is a big beefy boy of that really, and that really deals with connectors like this, terminal connectors like this, and it has all the different sizes you can go to. Great little bit of kit, and of course a little cheeky flathead screwdriver, because you always need one of those with electrical stuff. That and also a small Phillips. But yeah, a few little tools here that will make a world of difference. Some further things to add about this system is this system doesn't include an inverter. A lot of people need an inverter or use an inverter, and they can be really simple to connect to a system like this. Providing you have a big enough battery and it can support that sort of power usage, you usually get an inverter with a positive and negative cable that will connect directly to the terminals on the battery, and they'll go off into the positive and negative terminals of the inverter. But you do want to put a fuse in line on that inverter, and the size of the fuse usually depends on how many watts that inverter will provide. And then on the bottom of that inverter, it just had the plugs ready to rock and roll, and you can, maybe make an extension cable that would lead somewhere else in the van, and have plugs throughout the van. So another little easy addition to add to your system. I just didn't have one lying around at the workshop, so I couldn't show it in this layout. Another honourable mention would be conduit tubing. You're probably going to see quite a lot of this. If you need to feed cable through tricky spaces that otherwise might damage a cable while the van's moving around, you're going to need probably tubing similar to this. So if I was trying to feed my cable through this hole here, or even a freshly cut hole that might have sharp edges, even if you have deburred it, you can basically just feed the tubing through the hole to bypass the sharp edges, and then this will allow you to feed that cable through that bit of tubing all the way around and avoid it getting shredded on the sharp metal. Also on the solar front, as I mentioned before, MPPT chargers. There are so many different types of solar chargers. You can have ones as basic as this PWM one, or you can get like really nice ones, stuff like Victron, that have like Bluetooth capability, and that allows you to use an app to log into them and see the sort of what's coming in and see how much power is coming in from your solar panel, so you can sort of maybe help gauge and regulate how much power you're using. And you can also get stuff like shunts that will go between all of the negative cables coming into your battery and the negative terminal, and that will give you like a readout of the absolute complete power usage in and out of your whole system, so that you can see how many watts you're using at any one time. And that's a great little thing to add on as well if you can afford it. There are so many different gadgets and things that you can keep adding to your system out there. I have nowhere near enough time to list all those different things, but the things that I have mentioned in this video are there to basically get you started, give you a working system and a few different options on how to approach it and how to keep it running and keep it simple and keep off grid. And I'd like to thank all my DIY nomads so much for watching. If you're not subscribed, please subscribe, it really does help out the channel. I'll catch all you guys next time.